Welcome to the Got Academy podcast.
Goodbye, Rose, the queen of Corona.
As the world closes down with every passing day, we have heroes on the new front lines of science trying to find a way to get us out of this mess. And in this podcast, we're going to talk about the race for the cure.
In some ways, is this a new type of arms race?
I think probably the best kind of arms race in that we're not working in opposition with one another, we're working in collaboration with one another.
Hi everybody. Hi Dr. Ruger Vos. How are you doing?
Hi Gil, I'm good, thank you. I guess there are some people who might be bored because they were hoping to see sports competitions, which I don't really care for, but other people might. But there's a new competition to watch, and there's other heroes, besides obviously the healthcare workers and the people providing the shops and all the other people who keep civilization running and who are chronically woefully underpaid, but they're actually the important ones.
Wow, underappreciated also.
Absolutely. But there's also the scientists who are racing to find a cure. Whoever is going to be most successful gets this situation, helps get this situation under control. I guess we can be pretty sure that that person gets a Nobel Prize very quickly, because we are in such an unprecedented situation. It's inconceivable that this would go to the stomach ulcer guy this year or something like that.
So we have been told that everything in the world runs on greed. Everybody is greedy. Everybody's doing everything for money. But somehow I have a feeling that the scientists who will save us all from this impending doom will be happy with worldwide global recognition, love and adulation, and not will just like get a patent and sell each dose of the cure, $50,000. Come and get it. I guess now things are going to be different in so many ways.
Well, scientists, most of them, don't do it for the money, especially not in basic research, for example. And there was an interesting quote the other day. One of the scientists was asked, where's the cure? How's this going? And she said, I think she was Spanish, and she said something along the lines of, look, the PhDs and postdocs who do most of the research are getting paid like 1,800 euros a month. And Messi is getting paid millions. Why don't you ask Messi for the cure? See how that's going. And of course, he's totally right. There's a strange discrepancy in, people doing important work and where the money's going.
Yes, I'll tell you where she was wrong though. I saw that I also got it on my WhatsApp. She was wrong. She said we're being paying 1,800 euros per month, but Messi and Ronaldo, they're being paid 1 million euro per month. And I was like, if they had to cut down to get down to 1 million euro per month, they would be like, no, they're getting, I think it's more like they're getting like almost 20 million euros per year. So that's, no. They'll have to cut down on
so
their,
they're getting a bit more than
on
1.5 million euros a month.
How will we make do?
It's incredible. Yeah, okay.
Yes.
Okay, they're getting about 1,000 times as much.
And they're still getting paid, by the way, right now.
Right.
They're doing less than what you and I are doing now, working less, and they're still making this money. Okay, but let's get into details. What are the efforts being made out there in order to get the cure? What kind of cure will it be? What are we looking for? What are the odds, timetable, everything? We want to know, Rutger.
I think there's three main things to hold out for. So one of them is better testing, which is actually incredibly important.
Okay.
So South Korea looks like they've been relatively successful, and they've accomplished that with just enormous testing at a very large scale, which then means that you can isolate the infected quickly and also do contact tracing, and then everybody else can just keep going to work and so on. So that is going to be necessary just because we can't all stay in our house for months to come. So testing is one of them.
Yes.
The second one.
And how is that? Okay.
Yeah,
you want to first do an overview and then we'll go into each one?
Okay. Layout as I see it.
Go ahead.
So there's testing. The second one is treatment.
Mm-hmm.
So you get sick, somewhat bad, which is maybe like 20% of the cases. So you need to be treated, just like what happens now with the people who are in hospital beds right now, right? And then the third one is prevention. How do we make it so that we're just immune to this thing in our societies as a whole?
Okay.
So that it doesn't just come back right away. Because if we have testing in place and we manage to get it under control, well, as soon as you let it up, then it comes back again because none of us are immune. And so that needs to change. So testing and treatment and prevention, I suppose, vaccination.
Vaccination. That's the three pillars of the scientific resolution of this pandemic. Yeah. Okay, so the testing. What kind of testing do we have now in terms? First of all, in terms of science. Afterwards, we can get into in terms of who has the testing. How do you deploy testing to every country? Blah blah blah. First, in terms of science, what kind of testing do we have? How does it work? And
sure.
Is it complicated?
Well, there's three different types. Kind of the standard type, which turns out to be this big bottleneck, is a form of PCR, is what it's called. And just to sort of unpack what that means. So PCR stands for polymerase chain reaction. And so what does that mean? Well, I guess we know what a chain reaction is. So actually that first was kind of defined in chemistry, but I guess we all know it from nuclear explosions and from Chernobyl and so on, right? Like an atom breaks into pieces, the neutrons go flying, bump into their neighbors, and if they're close enough to the neighbors and there's enough of them, then the fission, the breaking of the atoms, increases exponentially. A lot of energy is released, and boom. So chain reactions are exponential growth, just like the growth of the virus again. There's also exponential growth if chemically you duplicate an RNA or a DNA strand, and you then duplicate the duplicates, and you duplicate those duplicates, and so on and so on. So you get exponential growth in the amount of DNA. You design what's called a primer or a probe, which connects exactly to a bit of RNA sequence that is characteristic for something. So in this case, for the virus, right? So you have to design this bit of synthetic DNA that attaches to what you're looking for, and then you do the copying with the PCR reaction. So you get many copies, and then you can easily see, there was something there or not, just because you amplify the signal that's there. But that was, by the way, the Nobel Prize in 1993 for Mullis and Smith for PCR.
So that's an old.
So that's an old one. So that's the first kind of testing that we have, PCR. Another one that's a bit quicker is to do a CT scan. So this is, the patient lies down and basically you're virtually chopped into slices, right? And those are assembled in some kind of model, and then you can see something bad's going on in the lungs, and there's like a particular kind of thing that the doctors are then looking for, like your lungs look more clouded and with something that they describe as glassy in it.
Okay, that's the big machine that gets you inside, right? The round thing, right?
No, so it's not an
like
MRI.
An MRI,
so
or
that's
is
an
it
MRI.
different?
The big clunky machine is CT scan is you don't go in the whirring, bing, ding, 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 noisy thing. It's a different type of scanning. But that was Nobel Prize 1979 for Cormack and Hounsfield. Yeah.
Oh, we're going back in time. Okay.
Yeah.
Gotta get back in time.
And then the third type of testing is what's known as an immunoassay or an ELISA test. So that works with antibodies. So
antibodies are?
Yeah, so let's say, okay, something comes into our body, like a virus or bacteria or something else that shouldn't be there, something maybe that we are allergic to or something. Think of it as like it's a little machine with nuts and bolts, right? It's like a car that is parked in the wrong spot in your body. Yes.
Inside our bodies.
And then our immune system is going to try to take that machine apart. And so it's going to look for the right wrench because it sees, okay, this thing has a lot of different nuts and bolts. Can we find the wrench that fits on the nuts and bolts? And once it finds the fitting wrench, which is the antibody, then the immune system has leverage and it can take the machine apart, right? So I guess the jargon is like these nuts and bolts, they're called epitopes, and then the antibody tries to attach to that. And then once there's the antibody, then your immune system can do things like there's these white blood cells can come in and see, oh, there's something here marked for deletion, and they just basically eat the thing, and then it's cleaned up. But just because that exists, we can also make those antibodies in a lab and use that for detection. Right, so if you have the wrench and you have the leverage on
for detection,
on something. So let's say you take a swab of somebody's throat, right, and then so there might be viral particles in there, and then if you have the antibody, then the antibody attaches to the viral particles, and then you can make the antibody somehow visible, like you can stain it and it shows up with a different color, or it's fluorescent or something like that.
Okay. And then you see the reaction, then you know that
there.
there's the coronavirus there.
So there's two Nobel Prizes for that. There was the whole notion of the immune system was already in 1908. There was Ehrlich and Metchnikoff. But then something that's kind of new is the development of what's known as MABs, or monoclonal antibodies. And they're being used, for example, also in cancer treatment. And that was the 2018 Nobel Prize for Ellison and Honjo. So one of the innovations now in a paper that was published a week ago, March 12th, was the development of a monoclonal antibody which neutralizes the virus. Right, so the virus can be detected by our immune system, right? Where you get sick, then our immune system at some point learns to recognize it, makes the right antibodies.
Right. Temperature rise, your body's fighting.
Yeah, and like for a lot of people, like 80% just recover by themselves. Their immune system works as advertised, which is that it makes the antibodies and then it clears up the viral infection. And so what these people have done is they made specific antibodies in a lab that can do that for you.
Okay.
Right, so that works with like their specific cell lines, which are clonal, so they're exactly identical, all the cells in the cell line, and they make the right antibody, and so that's how you make that, right? So this is a class of medication where the name always ends with MAB, and they're being rolled out in a bunch of different settings. Now, to make this work as medication, that's going to take a while, because then you have to test it in people and get the approval, yada, yada, yada. But to use it in tests where you don't stick it inside a person, of course, that's going to be easier to get that approved, right?
How does it help if you don't stick it into a person?
For the testing.
For the testing, but okay. Okay, just for the testing.
We're still kind of on the topic of testing, right? So there's I guess 3 different ways. There was the PCR thing with the DNA RNA thing. Okay. There's the scanning, where you just make a photo of the lungs basically, or scan. And there's the immunoassay things where you have these antibodies and they pick up the virus, and then that's how you, from a swab of sputum or whatever, you can detect that it's there.
But so just to recap the testing, and then we'll move to treatment.
So there's 3 types of testing. There's the PCR mechanism, which detects the RNA of the virus. There's the scanning, where you just look inside the lungs and see if they have the symptoms of the disease. And there's the immunoassays, where you have these antibodies which see if there's viral particles in maybe like a swab in somebody's throat or their nose, or maybe deeper in the lungs, for example.
Okay. And it's very important to know as quickly as possible who has the virus, because it's very infectious, and we want to quarantine and isolate the people who have it, because so that if every person infects 2 people, then a lot of people will die, and economies will be ruined, and societies will be in shambles.
Yes. And we also want to know who's already recovered, actually.
Right.
Because they can just go, they can keep civilization going. So that's kind of important too.
And who has the testing? Before we move on, who has these different testing? Who's doing what?
The scanning is just in the hospital. Like a patient shows up in the hospital, they put them in the scan, they can have a look.
Okay, that's not very efficient though.
No, actually all of these tests are done by hospitals, or maybe like by testing facilities that collaborate with hospitals. But I guess it's different labs, right? Like the PCR thing, it's kind of like a molecular lab.
Nothing automated. You just have to look, like a single person just putting something in a petri dish, and he's looking and stuff. That's the way that it's done now. There's nothing that can be done quicker.
Well, it is parallelized, and so there's especially like for the scan, an individual person has to go in the scan. The swabs, like people have to do something with the tube and see what's there. And the PCR, like there's like parts of it is like with pipetting and stuff, and there's robots that can do that. And there's like a sort of a parallelization where within a single PCR machine you can have, I don't know, like maybe 96 samples or something like that.
Okay. And what's the South Korean drive-through thing? Which one of these is that?
I'm not sure, but I guess it's
Korean drive-through thing. Which one of these is that?
I'm not sure, but I guess it's the immunoassay thing. So it's like you get a Q-tip down your throat, and then they put it in a tube, and you get a result.
Okay, and then they just test it later. It's not okay, you're good. No, you're sick. It's not immediate.
No, I think it's like maybe 20 minutes or something like that. So it's somewhat quick-ish.
Wow, incredible. I want to move to South Korea. Okay.
Yeah.
Okay, so testing, we got the testing done.
Yep. Well, we're working on the
at least in this conversation. Okay, so the next one.
Next one is treatment. Let's say you are sick.
Treatment.
What's being explored now mostly is what's called off-label use. So this is this idea that there is medication already that's being used for something else. Malaria, and so that's approved, like that. And doctors can already prescribe it. We just use it for something else. And that's how a lot of medication just comes into existence in the first place. Like Viagra, I think, was for blood pressure.
Right.
And then it turns out it makes your dick hard. So basically this is all off-label use. And so that's what they're trying. They're trying to find things that work for that. So, for example, the announcement that Trump made Well, here's what he was referring to. He was referring to this paper that came out a couple of days ago, where actually they applied a combination of two medications. One, the hydroxychloroquine, which I guess now there's a run on that medication, which is kind of dumb, in combination with azithromycin. So the hydroxychloroquine is actually something that is prescribed either for malaria or for things such as lupus and rheumatoid arthritis. So it does something with the permeability of membranes, and the thinking is that it somehow inactivates the virus, because the virus also is engulfed in a kind of membrane as it enters the cell, and there's some trickery that you could do with that. And the other one is the azithromycin is an antibiotic, which antibiotics are mostly used for against bacteria, we might remember, but this one also has some antiviral activity, and so then we combine them. Like the small study that was published had very promising results. So the thing that now floats around on social media is that there was 100% recovery within 6 days. So we have to subtract a little bit from that. So the people that were at the end of the trial still in the test subject category, they recovered, but there was also one person that died, and 3 other people that dropped out of the trial.
If one person died, how can that be 100%? I don't know. I'm not that good in math, but
well,
it seems
there you
off.
go. So of the people whose viral load could be measured by the end of the trial, there was 100% clearing of viral load. If you discount
the people who survived, 100% survived.
Right. Now it still looks pretty good. But it's a very small study, and it's also a study that's not a randomized, controlled, double-blind trial where neither the patients nor the doctors know what is being given. So this was, people that said, "Oh yes, I'd like to try this," and the doctor says, "Oh, this is something that might work," and that really influences the results. So because there could be self-selection among patients, and But who knows?
You need to give half of them placebo, I guess, in order to find out. But no, is that how it should be done?
That's how it should be done. And then nobody should know who's getting the placebo, who's getting the real one. So it should be hidden, that kind of thing. But now they're starting bigger studies to try that out. Like this was just like a long shot. Let's see if this does anything. And it looks encouraging, but who knows?
But can you give people placebo and then they just die?
Well, that's the big ethics question, obviously, right? Like, are you giving people sugar pills and then they contributed to the healing of the world by dying?
Oh no! Oh no! Okay.
But so that's what Trump announced, and then what's actually kind of going wrong right now is that there's a run on only one of the two drugs which actually are more active in combination, namely the hydroxychloroquine. And that's a problem because it's also being prescribed to people who definitely benefit from it, namely people with rheumatoid arthritis, lupus, maybe some other things as well. And now there could be shortages because of his press conference, right? So.
Oh, that's, I don't know. When you said something about Trump announcing something, I really felt like it was going to be sane and really had a good result and everything would be fine. And now just like taken aback. I don't know. Wow. So it backfired in some way. Wow.
Yeah. Unintended consequences. Yeah.
Who could have seen that?
So that's something that's being tried. Another thing that's being tried is a medication that's normally being used against HIV.
Right.
So there's this other combo, which is the brand name is Kaletra, which is a mix of lopinavir and ritonavir, so anything that ends with vir is antiviral, right? Just like MAB is monoclonal antibody. So what are these? Well, these are protease inhibitors. And the way that works is, the virus, just quick recap, we did this last time as well, but just again.
Yeah.
Okay, so
we need it.
there's the code. There's, a bunch of codes that describes how to make a viral particle, right? And that code is written in DNA, or actually in RNA, but RNA is basically the same thing as DNA, structurally slightly different, but okay.
Okay.
And that information that's wrapped up inside a protein envelope, an outer shell, which is basically the packaging, right?
Okay.
And so then what needs to happen is this package and all that needs to enter into the cell. So what the medication that I mentioned, the hydroxychloroquine and the other thing, is supposed to do is that fucking around with the entry into the cell. Then the next step is, well, it has entered into the cell, and now the package opens up, and out comes the RNA, and now you, the person, well, now under bad circumstances, your cells are going to read that information and execute the commands, right? So you're doing the work for the virus. Your cell machinery reads the code and starts just doing what it says there, right? And what it says is,
which is infect your body. Basically,
well,
that's
so the instructions. So think of it like this. So our body might be like a factory that makes USB sticks.
Okay.
Could be
an old-timey machine.
A factory that makes USB sticks. Right. Here comes a malevolent USB stick. And it has on it as the data, the instructions for making malevolent USB sticks. And it tries to get you, the factory, to read out that information and start producing more USB sticks.
But malevolent ones.
Yes, malevolent ones. And so then there's the different components that form the hardware of the USB stick. There's, the bit of metal. There's the plastic thingy that maybe looks like fuzzy dice or whatever, a little car, I don't care. And those components, they are first produced sort of glued together as a larger module, and then that needs to be cut into pieces. Like, so my older brother, as a hobby, when we were little, he built these fighter jets out of these plastic models. And you buy like the model, and it's this sheet of plastic with all the different components attached to the sheet. It's like flat, and there's like the nose cone and the fuselage and the wings and all that. And then you had to first cut all these pieces loose and then glue them together.
Right, I remember. Okay,
and that cutting part, that's important here. So cutting the pieces loose from the larger sheet.
From the package.
From the package.
From the first package.
Yes.
Okay.
So that's done by an enzyme called protease. And so if you can inhibit the action of that enzyme, then everything stays in the packaging and no new fighter jet or USB stick or whatever is being built.
Then it just sinks into the bottom of the ocean, the package.
So that's what we want. So that's what a protease inhibitor does. And that's been rather effective in the treatment of HIV.
So we have that. We have those kinds of things.
We have those kinds of things.
For the HIV,
the proteases,
autoimmunic.
They are the little tools or the scissors that allow you to cut open packaging. They're specific for each virus. So you're kind of hoping that the protease inhibitor that you've designed for HIV is going to work on another virus. And it doesn't look spectacular. It looks like maybe it works a little bit.
And how long does it take? I hope I'm not intruding to another part of the stuff that you want to say. But let's say it works some, but not spectacularly. How long does it take to redesign it to fit exactly this virus? While we must remember that I guess this is like priority one for every fucking lab in the world. Like all you other people with the other maladies, to the back of the line. Okay, this is priority 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Well, under
How
normal
long does it
circumstances, that takes many years. Under normal circumstances, that could be a decade, right? So that's why we want these off-label things to work right now. Of course, everything is going to be sped up, and approval procedures are going to be quicker.
Money.
Yeah, and like different testing phases might be parallelized. Like there's like phase 1, 2, 3, and in some of them you just test. Okay, if we give this to people, does it kill them? And then next question, if it doesn't, does it actually do something useful, and so on, right?
Okay. Okay.
And then in animals and so on, and so we can try to parallelize that and make things go quicker. But still, this is not like next week. This is going to be years, right? To design one specific
years.
Yeah. So that's why we all hope that this off-label use works, because to start from scratch.
Years? Why years? Why does it take years? How long does it take to get results? Why does it take so long?
First of all, just designing the thing, that's not so straightforward, and there's often just an element of luck to it, I think, as well. Like you have to try out a whole bunch of different candidate molecules, see which ones work in vitro, like in the test tube, and then, test.
If you enlist, humor me here, right? I'm a layman, okay? If you enlist all the people doing their postdoc or whatever, second degree, and you build labs and you build whatever, the machines, the testing machines, and we have, thank God, we have so many people who are sick, so you can have a lot of stuff to test with. And everybody tries something, whatever, tries a little variant of the other thing, and everybody's trying, and you have thousands and thousands of people testing every single day with shifts, 24-hour shifts. Doesn't that... okay, you're making a face like you know.
I have no idea how much faster it would go then.
About the shifts, people testing in shifts, I just want to say that we're recording this on March 21st. This is a Saturday. So in Israel, we stopped 90% of the testing Friday night because it's the Shabbat. The Shabbat. We're not testing during the Shabbat.
I'm sorry. This is not something specific to Judaism, but all religions are really showing them from their worst side right in this crisis. Wow. Let's all have prayer meetings. Let's all get together by the thousands. Let's lick the relics.
Even though in Judaism. So even though in Judaism you have a specific law that said that pikuach nefesh doche Shabbat, human life is superior to the Shabbat.
Choose life.
But still, choose life. And also we have ultra-Orthodox communities here who still kept congregating and meeting and teaching. Wow, they're going to get so sick. This is incredible. Yeah. Okay, go on.
Yeah.
Yeah, people are going to lose their religion after this, because all those religious leaders who just said, nah, it's fine, go pray together.
Well, that's how
you
the
had
Renaissance...
like weddings.
The humanism of the Renaissance.
Yeah. After the Black Plague. Right.
So anyway, protease inhibitors. Another off-label thing that is... being fast-tracked to approval, or I guess where it is now is they're now doing the phase 3 trials, which are going to be over by the beginning of April, and then we have more results. This is for a medication called remdesivir.
Okay.
It's another antiviral which was designed for Ebola.
Okay.
And it's a gigantic virus which... it looks different. It's not this ball with the spikes. It has these filaments, kind of like snaky looking.
Yeah.
So what this medication does is the following, because both Ebola and the coronavirus obviously want their codes to be read out, right? Like, remember, the virus tries to get you to execute its code. And so the way that works is by reading out the RNA, DNA code, and by then making what's known as a reverse transcript, which is it's kind of like there's the negative image, and then it first needs to be turned into a photopositive image, and then something is being done with that. And so so you need to make some kind of like a complement of the code. And to make that complement, you need to insert new DNA letters one by one along the double helix.
Okay.
Right? So you need
in order to change what it's doing?
No, just to make copies, basically. Right? So you know, like, okay, there's normally it's like the double helix, right? Like the little ladder shape.
Mm-hmm.
You zip that open so that you have two single ones. That's normally how it works, also in PCR. And then on each of the single ones, you can put the complementary letters on the opposite side of the single strand, and then that's how you make a copy. So what this remdesivir does, it's kind of like one of those letters, except it's malicious in that when it's inserted, it stops the rest of the reverse transcription. So then it's like you inject some malicious code into the code of the virus, and then it stops being read out. So we can kind of hijack its own code.
And did Ebola also start from it's like an animal virus that infected us, right? Like monkeys or something?
Yeah. So I'm not sure if it comes from monkeys. I know that great apes also get it, like gorillas, so on.
And they get sick from it?
I thought so. Yeah. I'm not sure if it's exactly the same one or if it's like a slightly different variant of the virus, but yeah.
Okay. So we want to take that, basically stopping the recreation or the pressing the enter button, tick tick tick.
Yeah.
Just stopping that with the Ebola. Okay. And how is that working out so far?
So we're waiting for the results of the trials. Right, so
we don't know anything about them yet.
So we know a little bit, but only anecdotal. Actually, the very first patient in the US, he was given this under what's I think called compassionate use. So then the hospital needs to ask the producer, Gilead, which is a pharmaceutical company, can this person enroll in this special trial for people who are basically so sick that you might as well try anything? And then he was given that, and he recovered. And there's a couple more cases of that where it's being administered on an experimental basis, and it seems to be doing okay, but there's no stats to back it up. It's just like anecdotes. Yeah. This guy got better. Yeah. Well, maybe he would have got better anyway.
There's also an Israeli guy that also was about to die, and he was given, I think, either the HIV or the malaria one, and he also got better. Yeah. He was just like this close to dying. He was on a bus with South Korean tourists, and he was like the first really, really serious patient, and now he's fine. Yeah. Okay, but anecdotally, so it means that it helps some people. I guess that's the thing. What's how come it helped him?
Well, we don't know. Right? We don't know. Like you need to have sufficient numbers to say, well, it has actually had a significant effect. Like somebody could have just got better, just like by himself, and that they gave him the thing was just they could have given him a placebo and he would have still got better, right? And only if you do the actual testing can you tell, no, this wasn't just a fluke, this was a real thing.
So we might have something by the end of April?
So we get the results earlier in April. I think the beginning of April, the trial results are going to be in.
So we might all be saved in 2 weeks?
I hope so. I'm not praying, but I hope we are.
This is why we stopped the testing yesterday, to pray for this. Okay.
Yes.
Okay. Are we now into the cure phase of the conversation? I wanna feel like there's something to look forward to.
Yeah. So
Positive.
here's my own submission for the Nobel Prize.
Okay.
So it works as follows.
Breaking news!
Yeah,
Breaking news, everybody.
So it works as follows. Like we went over how the immune system works, sort of, like it develops these antibodies. And so if you're a healthy person, and maybe with a bit of luck, all comes together, you figure out the right range that takes apart the virus, you're cured, nice. And then you have the antibodies in your system, right? Because that's also how we can detect it. Now, here's a really old trick, which is we can use the blood serum of recovered people and you give like a transfusion to very sick people and cure them with the serum of recovered people because that serum is going to contain the antibodies. Actually, and
So every single
really
cell of our blood will have it?
What? Sorry?
Every single cell of our blood. So if I'm cured by myself, then you take the blood, then this portion of blood has...
So it's the blood
cure.
serum. So it's
What does it mean?
it's not like the red blood cells. Actually, you would centrifuge the blood and take. So the serum is going to look like, I don't know, juice, not not tomato juice, but more like apple juice.
It's going to take like the essence, whatever, of the
So
blood.
the
whatever,
antibodies
blah, blah, blah.
are just proteins that basically float around on their own in the blood. So it's not really the cells, it's just like the biochemistry of the blood. Now, just by it's not living, but...
So you centrifuge them and then you give it to somebody else with the same blood type,
I guess
blah,
there's
blah, blah.
two steps. One of them is inactivate any viral particles that might still be floating around. And then the other, get the red blood cells out of there. So centrifuge to just have the juice, the liquid, and give that to a sick patient. And that's being used, like that's a 100-year-old trick, right? And that's what was used in other outbreaks. It was used against polio and Spanish flu.
Really?
Yeah. And it's also, for example, how they make, not anymore, I don't think, about how they used to make snake anti-venom. Like you give the snake venom to a horse, and the horse gets really sick, but not so sick that it dies. Then we tap the juices, and in it is the anti-venom, because that's just an antibody.
So you don't have even to have the same blood type or whatever.
Well, that
because
helps.
It's just the juice.
Yeah, I think with anti-venom they do a bunch of purification steps, which maybe we don't have time for now. So if you do it, just you administer the serum, you do want to have the same blood type and rhesus factor, I think.
So is anybody doing this? What you just suggested?
A little bit. So the Chinese had been doing it in the US. There's now so Johns Hopkins is gearing up this massive protocol to organize this and administer it. And so here's my proposal then for my
this
my
is an
Nobel
official
Prize.
statement now.
Is as follows. So we know that actually young people in their 20s, they don't get as sick with it, right? Like for them, the mortality
Kids
rate,
even less, no?
Sorry?
Kids even less.
Yeah. So I think the mortality rate was like 0.2%. So then you're kind of in flu territory, right? Kind of bad flu. But actually they are massive carriers of this. The more we test, the more we're finding this out. And for example, the numbers in Korea show that actually the age cohort that has the most infected is the 20-somethings. So a lot of them are walking around.
We are massive carriers,
yeah.
But we don't feel anything.
Nope.
Not we, because we are not 20-year-olds.
No.
Sadly.
The millennials or below that, even Generation Y.
Okay, Z.
Yeah.
Z.
And so here's the solution. Okay, they can just go about their business. We open up the festivals and all the rest. Just go have fun. It's fine. And then if they get sick and they donate their serum, we waive their student loans.
But what about those who don't have student loans? They get money.
Yeah, or the equivalent
other loans,
is money.
credit card loans.
Like maybe per session, it's like I don't know, like $5,000, something like that. That's I think.
Okay. Okay, and then you take that serum.
And that you take that serum, and then you can either
You
give
drink
it
it.
as a prophylaxis, so you give it to healthcare workers who are exposed, and that protects them, or you can give it to the sick, but you have to be quite early on in the treatment. So again, we have to have massive testing, because then people, before they are like super duper sick, then it still kind of helps. And because that kind of takes us to the next stage, which is the stage where almost the virus no longer matters. You're just like, your lungs are so messed up and inflamed and oozing pus that you're just choking, right? And so there's kind of a treatment which is not really antiviral, but that's just against the inflammation, which is another of these monoclonal antibodies which is being administered, which is called tocilizumab, which is an interleukin-6 inhibitor, which is normally given again to people that with, I think it is like an anti-rheumatic, so rheumatoid arthritis type of thing.
Okay, I wanna go back to your millennial blood, drinking millennial blood
To sustain
solution.
life, yes.
To
The
sustain life,
Dracula
we need
option,
we need virgin blood.
Exactly.
So, okay, so this has been prophesized. But so, how long does that take to test? Is that being tried, or is that what's going on? What's the timeline on that, as far as you know?
It's being done now.
And there are anecdotal results.
Yes.
Good results.
Well, it's part of the standard protocols that were being used in China, and now they're trying to roll it out in the US.
Okay.
Yeah.
Okay.
So
okay.
this is
Sorry.
not like far away in the future. This is something that might be doable. Let's fingers crossed. Let's hope that this does something. But in general, this is a treatment that works and has worked in the past.
Okay.
Except, of course, scale is then an issue, because then how do you get the donors? If it's just all voluntary and like, oh, you're a very nice guy, thank you for donating, that's not enough. So there needs to be some incentive. So here's the
let's
social
give the money.
engineering.
Societies run on greed.
Right.
Okay.
And also
Okay,
there's
because-
like the lifeblood of the younger generation is handed over to the boomers, but then the wealth, which is just locked up in these outstanding student loans,
Right.
is transferred to the younger
Yes.
generation, which also then is good for the
Yeah.
economy, because then they go and spend, and then we all recover.
Yes.
Yay!
So it's the blood trickles from the boomers on down back
Yes,
to the
it's-
millennials.
Exactly, it's trickle down.
Trickle up and down with a straw. You take a straw, and then some of the blood trickles down. Okay, that sounds like like a business plan, a business model. Basically, you buy the elixir of life.
Yep.
Okay, so we haven't yet got. So this is not the immunity thing, yet, the vaccine.
No.
We haven't gotten to the vaccine yet.
Yeah. So vaccines, that's starting up now. The first trials of vaccines have started. And there's like, there's different techniques. So in general, in vaccines, there's different types. Like there is ones where basically you attenuate the virus, so you don't
Attenuate,
get
what
as
is that?
sick or kind of sick, and then
Yeah,
you
okay.
build immunity against that weaker one, and then when the real thing comes, you're protected.
Yeah.
But for example, what they now started testing is one where they inject you with the RNA that codes for the spikes on the surface. So you first build the spike protein of the virus, so not the whole virus, but just the outer thing, which is
The image that we all
the
know.
image that we all know.
Okay.
That's otherwise, relatively harmless. And then you, in response, also build the antibodies against it, relatively harmless. And then you, in response, also build the antibodies against that thing that you just built yourself. So that's being tested now, but that's going to take a while, Like they keep saying about
this
the,
from
about
what
the
I read will
vaccines,
take a
they're
long
saying, well, like they say, well, 12 to 18 months, maybe.
12 to 18 months. And what about anti-vaxxers out there?
They're very quiet right now.
Should-
I have heard very little from the anti-vaxxers.
Okay, so the last week or so, I haven't heard anything. But the week before, and I'm ashamed to say that I heard that I heard quite a bit from them in a vegan Facebook group. They do not represent the vegan community, but there were like 4 of them in a conversation about will they accept the coronavirus vaccine, and like 4 of them out of whatever 40 people who commented, that's quite a lot, whatever, they were like no, and if I give it to the people close to me, then I guess that's it. And then I was like, are there still people close to you if that's how you feel? But so, should we like force everybody to get the vaccine, or if some people do not get the vaccine, then that they could mutate somehow, their body could mutate the virus and then kill us all again? Also, after we talk about the vaccine, I want to talk about what we do to prevent the next pandemic, because this could be much, much, much worse. I think in many ways we are very, very lucky. This could be more harmful to children. Just imagine.
Yeah. If it was the other
If
way
this
around.
was-
yeah.
If it was the other way around, society would collapse.
Yeah.
Would collapse. This is just incredible. Like people losing the children all over this, it would be insane. Also, it could be like the death rate could be much, much, much higher. Not the, it's very infectious, but it doesn't kill very efficiently.
No.
So we need to so after we finish about the vaccine, I want to talk about what can plausibly be done to prevent this from happening again,
Yeah.
outside of just like prohibiting, open air bat markets.
Yeah, well, to your question, should it be compulsory? I say yes. So
Because it's dangerous.
yeah, so we need to accomplish a high enough percentage. Okay, so for like one news cycle about a week ago, the British and then the Dutch said, "Oh, we're going for herd
That's a
immunity."
one news cycle. That's a million news cycles before. Right, herd immunity. Okay,
Yeah.
go ahead.
And then the idea was, well, if we get somewhere to maybe like 60, 70, 80% recovered, then we have achieved herd immunity. But herd immunity, that's actually a concept that comes out of vaccination. Like if that many people are vaccinated, then there's herd immunity. But just by letting it go wild, name me one example where we have achieved herd immunity to a disease by just getting sick. And is that how we
Right.
solved polio, smallpox,
No.
Black Death?
No.
Not really.
The Black Death just killed everybody, and the people who survived just survived, right?
Yeah, I mean, there
No?
could be a little bit of a genetic selective sweep, right? So,
Right. Right. And it took a long. It was how long did it? It's like decades.
the Black Death. Well, that's
Yeah.
been going.
No?
I mean, that has been coming and going for centuries.
Still.
Well, still it occasionally appears, but now we can just treat it, right, with antibiotic.
Okay. So the herd immunity is bullshit.
So the herd immunity is bullshit, and pretty soon, like for example, the prime minister, the Dutch prime minister, went on the news with the last time that there was a live speech of the prime minister to the nation was before I was born, was in 1973.
Wow. Really? We had like a gazillion. Okay, go ahead.
And so
very
he
lucky.
came and basically said, well, we're going for herd immunity, more or less. And then, people started to run the numbers, like, wait, so that means, okay, so
Yeah.
in this nation, we would have to have 10 million people recovered. 20% of those get seriously ill. So that's like 2 million clogging up the healthcare system. And
How many of those will die?
well, if all of a sudden you clog out the healthcare system, that's a
Yeah.
lot. Then maybe that's like 1 million who die, right?
Yeah. From all sorts of things, related and unrelated.
Yeah. So what the plan was now that a million people are
goodness.
going to die on field stretchers in gym halls all throughout the
Oh
nation.
my god, it's incredible how different is like our imaginary, the imaginary image that we have of leaders, of how they operate, what kind of facts they have, and the rationale that they have versus reality, which is just like starkly different. And it's embarrassing. It's embarrassing, and they just like reverse course like a day or two later. Like, okay, forget about
exactly.
it. Okay,
Yeah, the prime minister then came out with, "Nah, I didn't mean like that. That's not. I meant it in a different way."
Oh my goodness! He should be shot in the upcoming Corona trials later. I don't know. This is just like
well, I feel like they're
the
empty-handed.
Wuhan trials.
He's empty-handed, right? Like he, I guess at that point in time, it seemed like the right thing to say, just to make it sound like there is a strategy. No. And I kind of understand that. But this is obviously not going to work. The herd immunity thing, that's not what's going to happen. Just also because...
And even if it does work, a lot of people will die also. I read like the most optimistic, you can correct me if I'm misremembering it, that the most optimistic scenario has like 250,000 people dying. I don't know, I remember if it's in Holland or in the UK, but a number that is unfathomable. You're like, okay, I'm just going to let 250,000 people die and let's hope it works. This is your this is your policy.
Yeah. Yeah. So
no.
And but also when you like run the numbers, like even if it completely gets out of hand with almost total lockdowns, and you compare it to like how it went in Wuhan and the Hubei province. You don't get to the volume of people that have to have recovered. I mean, that's going to take longer than it will take to have a vaccine.
Right. You told me that, or I read it somewhere. It will take years.
Yeah, it takes years. So by then, we just have the vaccine. Then I think the better plan is to work from home and have a very controlled situation with a lot of testing, to fight the virus as best we can until we have the vaccine. Because then now you're saying, oh, we'll do this herd immunity thing, except we'll not get to that point even.
And what about putting in lockdown and restrictions people who are in the more vulnerable categories in order to not because what I'm most worried about, so each country has its own thing. Here we have democratic problems now because of the corona, but that's for another podcast. I'm more worried about the economic collapse and doom that we are all facing because of this than of the actual number of people dying. Of course, it will be a tragedy, but it seems that there's no plan how to stop and restart the economy. Why not put the people who are most vulnerable, put them in lockdown, and pay them whatever to have food and whatever entertainment, and have them whatever they can go around in specific times, all kinds of. I don't want to not put them in the gulag, and the rest of us can just with some restrictions, obviously, just function in some way, some normal way, so people can pay their rent, have enough money for food, for all kinds of stuff, because it seems like there's no plan at all that includes the economic side of this epidemic. Scientifically, will that work? What will be the impact of that if just the most vulnerable are contained from the rest of us? Assuming we are not vulnerable, we don't know, whatever.
That has to happen, I think. I mean,
you think it has to happen?
Let's say my parents, for example, they have adapted to the fact that they're going to lock themselves into their house, and luckily they have a bit of a garden and so on, for maybe a year and a half, Let's hope that by then, treatment, vaccines, whatever, have improved enough so that mortality rates have been driven down to the level of a flu.
Yeah. Your parents are lucky to have each other. My mom, since my dad passed away in November, she's very, very lonely. And I'm gonna keep my distance from everybody outside of my daughter, her mom, and her husband/partner. Even from my sister, I'm gonna keep like 2 meters away so I can spend time with my mom, because otherwise she'll die of loneliness. That's not any better.
Well, that is the main thing that we have right now. Is even if total lockdowns end, then our life is going to be very different in the way we work. And how shopping works, social life, public transit,
dating. I'm trying to imagine how dating is going to work.
Well, dick pics are
uh,
still possible, obviously. So,
yeah, but that's not actual dating. We'll talk about that later offline. Okay. When you meet someone,
that's always where
now you're
me.
supposed.
I thought that was the whole thing.
So usually two people meet, you like each other, you get close a little bit, you touch a little bit, you kiss, but now you'll have to show that you have immunity from corona. This is I don't know. I'm single. I don't know how shit will go down. I should have met someone earlier, settled maybe, just to have someone, because I don't know, for the next year. Like all the dating apps they're also gonna go bankrupt. Who's gonna go out on dates?
Well, I mean, in that respect, HIV is a bit of an example, right? Like there's dating for people who are both seropositive, for example.
But you don't know if you have the coronavirus or you don't have the coronavirus, right? HIV it's very easy to get tested.
Yeah, but here it's also going to be
put a condom. It's going to be easier, but it's going to take a time though.
Yeah.
Want to meet someone before, like I don't want to wait a year or 2 years. Come on, I'm lonely. By the way, I'm day 10 in home quarantine. Okay, 4 days to go. You are day 8 in self-isolation. Yep. How is it going? We want to do a podcast with Noga.
I'm getting used to it, to be quite honest.
Getting used to it?
Yeah.